Have you ever wondered what would happen if you fell into a black hole? Today, we're diving into the real science behind this cosmic mystery. Forget Hollywood. Let's explore the actual physics, from the stretching of your body to the warping of time and space. I'm Bisht, and together we'll unravel the secrets of black holes, guided by the insights of Einstein and Hawking. By the end, you won't just know the story, you'll understand the science. So buckle up as we begin our descent into the abyss. Keep your hands and feet inside the cosmic vehicle at all times, or don't. It won't matter where we're going. What is a black hole? It's not an object, but a region where gravity is so intense that nothing, not even light, can escape. Black holes are born from the death of massive stars, at least 20 times the mass of our sun. When these stars run out of fuel, gravity wins, collapsing the core into an infinitesimal point. This collapse triggers a supernova, blasting outer layers away and leaving behind a singularity, an infinitely dense core. The result? A hole punched in space-time itself, where the laws of physics break down. Some of those twinkling stars you see at night are future black holes, waiting in the cosmic dark. Understanding their origin is key, because their gravity shapes every bizarre effect we'll encounter on our journey. Black holes aren't just heavy, they're reality-bending. They're the universe's ultimate enigma. Let's get closer. As we approach, we meet the event horizon, the most famous one-way door in the universe. It's not a surface, but an invisible boundary where escape velocity equals the speed of light. Cross it, and nothing, not even light, can return. To outside observers, you'd appear to freeze at the edge, fading and red-shifting into darkness. For you, there's no warning. You simply drift across, unaware you've passed the point of no return. The event horizon is the information curtain, hiding the black hole's secrets from the universe. Once inside, your fate is sealed. All paths lead inward. The journey has truly begun. No alarms, no turning back. Only the unknown awaits. Let's see what happens next. Inside the event horizon, you face spaghettification, a real astrophysics term for a gruesome fate. Tidal forces near a black hole are so extreme, they stretch you lengthwise and compress you sideways. Falling feet first, gravity pulls your feet far harder than your head, elongating you like cosmic taffy. The forces become so intense, they rip apart molecules, then atoms, reducing you to a stream of particles. Spaghettification isn't just a cartoon gag, it's the raw power of gravity unleashed. Before reaching the center, you're no longer recognizable matter. You become a literal stream of elementary particles, spiraling into the abyss. It's a sobering, awe-inspiring end. Gravity here is untamed and absolute, and it only gets weirder. Gravity doesn't just warp space, it warps time too. Near a black hole, time slows dramatically compared to the rest of the universe. To distant observers, you'd seem to freeze at the event horizon, your signals arriving further and further apart. But for you, time feels normal. You cross the horizon in seconds. Inside, time dilation intensifies. Seconds for you could mean eons outside. In your final moments, you might witness the universe's future flash by. Stars dying, galaxies colliding, the cosmos fading. You become a one-way time traveler, unable to return. Time and space twist beyond recognition. The deeper you fall, the stranger reality becomes, and the mysteries only deepen. Black holes swallow everything, but do they erase information? Quantum mechanics says information can't be destroyed, but general relativity suggests black holes do just that. Throw anything in, a book, a spaceship, a person, and only mass, spin, and charge remain. The details seem lost forever, creating the black hole information paradox. Hawking once argued information is lost, but later proposed it might be stored on the event horizon or leak out as scrambled Hawking radiation. This led to radical ideas like the holographic principle. Maybe our universe is a projection of information on a distant surface. The paradox remains unsolved, a clue that we need a deeper theory of reality. What happens to information at the edge of oblivion? The debate continues. Black holes aren't eternal. In 1974, Hawking showed they emit faint radiation, Hawking radiation, and slowly evaporate. Quantum fluctuations near the event horizon let one particle escape, stealing a bit of the black hole's mass. Over unimaginable timescales, even the largest black holes will vanish. For supermassive black holes, this process is glacially slow. For tiny ones, it's explosive. As black holes evaporate, the question returns. What happens to the information they once held? Does it disappear, or is it encoded in the radiation? The fate of information remains one of physics' greatest mysteries. Black holes leak, fade, and eventually die. Even the universe's darkest prisons have an end, but their secrets linger. At the center lies the singularity, a point where density and gravity become infinite and physics breaks down. General relativity can't describe what happens here. It's a signal that our theories are incomplete. Some physicists suggest matter compresses to a finite, maximum density, a Planck core. Others imagine the singularity as a gateway to another universe, a wormhole. These ideas are speculative. We can't test them or see past the event horizon. The singularity is the edge of our knowledge, a cosmic question mark. Here, the very large meets the very small, and our best theories refuse to cooperate. The heart of a black hole is a frontier, hiding the universe's deepest secrets. It's not just a destination, it's a challenge to our understanding of reality. Black holes are real, and our universe is full of them. At the center of our Milky Way lies Sagittarius A, a supermassive black hole with 4 million times the mass of our Sun. We can't see it directly, but we see its effects, stars whipping around it at incredible speeds. In 2019, the Event Horizon Telescope captured the first image of a black hole's shadow, confirming Einstein's predictions. Black holes shape galaxies and anchor cosmic structures. They're no longer just theory, they're observable monsters. We can now study the abyss itself. The universe's most extreme objects are closer than you think. Your black hole experience depends on its size. Fall into a small, stellar mass black hole, and tidal forces shred you before you reach the event horizon. With a supermassive black hole, the event horizon is vast and gentle. You'd cross it unharmed at first. Only deeper inside would the forces build, eventually spaghettifying you. The bigger the black hole, the gentler the entry, but the same ultimate fate awaits. If you had to choose, a supermassive black hole offers a less violent welcome. You'd experience the weirdness of the interior before the end. The size of the monster shapes your journey, but all roads lead to the center. Let's put it all together. You approach a supermassive black hole, cross the event horizon without noticing, and are trapped forever. Space and time flow inward. The singularity is now your future. All paths lead to the center. No escape, no return. As you fall, tidal forces stretch and tear you apart, reducing you to fundamental particles. What happens next? Are you crushed into the singularity, added to a Planck core, or funneled through a wormhole? Science can't yet answer. Your journey ends with a question mark, not a bang. You become part of the greatest enigma in the cosmos. The black hole absorbs your matter and energy. Your final moments are spent at the frontier of physics. The ultimate fate, to become a mystery. We've journeyed to the edge of reality, stretched by gravity, warped by time, and confronted by paradox. Black holes force us to rethink space, time, and information. From gentle entries to violent ends, they're a testament to gravity's power. Now, what do you think happens inside a black hole? Is information lost, or is there a wormhole at the center? Share your theories in the comments. If you enjoyed this journey, subscribe for more cosmic mysteries. Keep looking up.